Okay, hello everybody. This is going to be just hopefully a quick video that's going to walk you through how we solve systems of equations by graphing. So we're going to talk about what a system is, how we solve it, all that fun stuff. So first things first, system of equation. What actually is a system? I've been talking about it for a while since we started chapter 6, but what is it? So a system of equation is two or more linear equations with the same unknown values. Most of the time we use x and y, but they have to be the same unknown values. Okay, the solution is going to look a little bit different than what we're used to. It's going to be any ordered pair that makes all of the equations in that system true. So if the ordered pair 1, 2 makes one equation true but not the other in the system, then it isn't a system. Okay, so here are some examples of systems, 1, 2, and 3. Okay, what I want you to do is I want you to take some time, look at the systems, and I want you to describe, first of all, words that describe with words what commonalities we notice in each three examples, and describe in words some differences. Oops. That we notice in all three examples, okay? So pause the video, take some time, do that. Okay, hopefully you notice some stuff, okay? For example, number 1, all of them, for commonality, they all have numbers. Every single one has numbers, 2, 22, -1, 2, 3, all that stuff. They all have x and y. Excuse me, they're all linear equations. So all of those are commonalities. Some differences are example 1, that one's not solved for y, but all the rest of them are except for number 3. So you have a bunch of different things, okay? But all of those turn out to be systems. They are two equations linked together with the same unknown values, x and y, and most of the time you use this brace, it's called, that squiggly bracket, to represent the two equations are together, okay? So what does a solution look like? That's easy. It's an ordered pair, we said. That makes everything completely true. So here we have this ordered pair right here. 4, 3 would be on both of those equations. So that's going to be our solution. It's going to be where the lines intersect. So all of your equations, all of your answers are going to be an ordered pair. So for example, it could be 2, 1. It could be -8, 10. It could be whatever x is and whatever y are. So those are an example. And for this particular example, number 2, it's going to be where the two lines intersect. So this would be the ordered pair 4, 3. That would be your final solution. There are 3 possibilities though, just like when we solved linear equations. 3 possibilities of what can happen when you solve a system. Your no solution, your one solution, and infinite solutions. So your no solution is, if you think about that example number 2, one solution was where the lines intersected once. No solution is going to be where they don't intersect. So you're going to have 2 completely parallel lines. That is going to be a no solution. Okay, so no solution are parallel lines with same slope but different y-intercepts. That's how you're going to get those parallel lines. One solution is going to be exactly like we just saw in example 2. You're going to have a line here and a line here intersecting at one point. So this would be your point. Hopefully it's going to intersect at a nice point like 1, 2 or 4, 3. Sometimes it doesn't though, but that where those two lines intersect is your one solution. Okay, so we're going to say that those lines intersect at one point. So different slopes have to happen. They have to have different slopes. Okay. Now, there's also one other possibility, and that is if they're infinite solutions. So what happens is you have a line here, and then when you go to graph the other line, it ends up being exactly on top of that line. That is an example of infinite solution. So every single point on that graph would be a solution. So they are overlapping lines. And that means they're going to have the same slope and same y-intercept. Okay, so that's our three possibilities anytime we're solving a system, so keep that in mind. So what we have to do if we're solving by graphing is just graph the two equations on the same graph and see what happens. Okay, it's a great visual. So let's take a look here. If I'm graphing A, I have two lines. I have the first line, which is y equals 3x, and then I have the second line, 2y equals negative x minus 14. First thing you have to do is you have to get these equations solved for y. That is the first thing. So I'm going to go ahead. First one's already solved for y, but the second one, I have to go ahead and divide both sides by 2. So this ends up being y equals, remember we need to take both parts, negative x divided by 2. Remember you have that imaginary 1 there, so that's negative 1/2 x. And then when I go ahead and divide negative 14 by 2, I get negative 7. So there's my new line that I'm going to graph. So one at a time. I'm going to start with y equals 3x. B is 0, because remember you have that plus 0. M is going to be 3, and you need to have your slope as a fraction, so 3 over 1. So I'm going to plot my y-intercept, and from there I'm going to rise 1, 2, 3, and run 1. Rise 1, 2, 3, and run 1. Or remember, if I wanted to do the opposite, I could fall 3 and go to the left one, because a negative divided by a negative is a positive. Now I do recommend you do all the points on the graph, because hopefully when I graph this purple line, that's going to overlap at a point. And if you don't continue, don't use a straight edge, it's going to probably intersect at a different point, so you want to be exact here. So y equals negative 1/2 x minus 7. So let's go ahead. We're going to start that y-intercept at negative 7, and the slope is negative 1/2. Remember that negative can go either in the numerator or the denominator. You pick, but not both. So negative 7, I'm going to go up 1, left 2, up 1, left 2, up 1, left 2. And you will notice that because I have drawn all the points, absolutely they intersect at this one point, which turns out to be negative 2, negative 6. That is my final answer. Okay? Okay, let's go ahead and take a look at B real quick. For example, B, I have to go ahead and solve both of these. So let's start by solving the first one. 2x minus y is equal to negative 5. If I go ahead and I need to get y by itself. So I'm going to go ahead and subtract 2x from both sides. Negative y is equal to negative 5 minus 2x. But I still have to get rid of that negative sign, so I'm going to divide both sides by negative 1. So I get y is equal to 5 plus 2x. Okay, so when I go to graph that, my b, y-intercept is going to be 5, and my slope is going to be 2, which is 2 over 1. So I'm going to plot 5 on the graph for the y-intercept, and then I'm going to rise 2, go to the right 1. Or I'm going to fall 2 and go to the left 1. There's my straight line. Now I'm going to do the exact same thing with the other equation. This one's a little bit easier because it already is 2y by itself. So I'm going to go ahead and divide both sides by 2. So I get y is equal to 4x divided by 2 is 2x, and 3 divided by 2 is 3/2. Unfortunately, that's not a nice number, so we're going to have to approximate that. So I go to 1.5 on the y-intercept, and then from there I have to go, my slope is 2 over 1. So I have to go up 2, so that would be 2.5, 3.5, and then right 1. Up 2, 3.5, 4.5, right 1. Okay? I can keep going here, but you will notice that since these slopes are exactly the same, 2 over 1, 2 over 1, what happens? They're parallel. So this is an example where since they are parallel, they have the same slopes but different y-intercepts. This is no solution. Okay? So what I want you to do the rest of the hour is I want you to try working through C, D, and E. Don't have to worry about F. Okay? That's more of like a challenge problem. But try C, D, and E. And that's your homework for tonight. Okay? Let me know if you have any questions.